Let's look at how to solve systems of equations using graphs. So the big idea here is that there's going to be a point where two lines might intersect, and that is the solution to the system. Okay, and sometimes when you graph two lines, they end up being the same line, and that's the case here. So this would have infinitely number of solutions, and then sometimes they're parallel, so there's no way for them to meet, and that would be no solution. All right, so it can have one solution, exactly one. It can have infinitely many or no solution. And then you just might hear some of this terminology. If it has a solution, either one or infinitely, they're called consistent. So they have solutions. If it's the same line, it's dependent. And then if they're different lines, then that is independent. All right, and then if there's no solution, you can also use the word inconsistent. That just means no solution. Okay, so let's look at a few of these. Okay, here I'm going to try and solve these systems. I want to know what two numbers for x and y would make both of these equations true at the same time. Okay, so we can figure this out by looking at what their graph looks like. Okay, so this first one, it's in y equals mx plus b. The slope is 3 over 1, and the y-intercept is 5. So I'm going to go ahead and plot my y-intercept, and then use the slope, go up 1, 2, 3 over 1. I'm kind of running out of space, so I can go backwards. I can go down 1, 2, 3, and back as well. All right, great. Now, let's see if I can get a line. All right, so there we go. Oh, sorry, my line isn't very good. Okay. And let's do the next one. All right, here this is not in y equals mx plus b form, but I can easily get it that way by just subtracting y from both sides, or x from both sides. So then this would be y equals negative x and 1. I'm not going to add those together. They're different. So I would just write them side by side there. So negative x plus 1, and then this actually has a little negative 1 is the coefficient of x. Okay, so the slope actually here is negative 1 over 1. So on this one, the y-intercept is 1, and then we go down 1 over 1 because of that negative slope. And so our line goes backwards like that, and the solution to this system is at the point negative 1, 2. So there's my answer. That's this point right here where they intersect. And if I can't really tell if I'm a little messy on my graph, I can just double check and see if that point works in the first equation. The first equation was y equals 3x plus 5, and so I'll just plug in 2 for y, negative 1 for x, and let's just see if that actually is true. And here we see that 2 is equal to 2. So it works on that one, and then we can just double check in the other one as well. X plus y equals 1, and that does work. Negative 1 plus 2 equals 1. Okay, so there's a double check if your graph maybe is just a tiny bit messy, you can't tell. All right, let's try this next one. It's really helpful to get this written in y equals mx plus b. So I'm going to just rewrite this over here. Let's see, I would have 2y equals negative 3x plus 6, and then I'll divide through by 2. So this one becomes y equals negative 3 halves x plus 3. Okay, so let's go ahead and graph that. We've got a y-intercept of 3 and a slope of negative 3, 1, 2, 3 over 2. Negative 1, 2, 3 over 2, and then I'll do my best to draw that graph. Good. All right, and on my next one, I've got x minus y equals 7. I'll go ahead and rewrite that in y equals mx plus b form as well. So negative x plus 7, divide everything by -1 here. So we've got y equals a positive x minus 7. So the slope here is 1, or 1 over 1. Great. Okay, so here we'll go ahead and do our y-intercept of -7, and then our slope goes up 1 over 1. And it looks like that is my point of intersection right there at 4, -3. And we're done. All right, I'm going to show 2 more examples. Here, you notice that we have the same exact slope. These lines are not going to have any solution because they're parallel. Okay, so in the first one, the y-intercept was -1, and then the slope is 2. Okay, so there's that one. And then here, my y-intercept is 3, and same slope. All right, and you know, my graph isn't perfect, but you can see no solution. Okay, one more. Let's see, I'm going to subtract 2x from both sides. Okay, so this one becomes y equals -2x plus 3. So we'll go ahead and graph that. There's my y-intercept of 3, and the slope is -2 over 1. So down 2 over 1 over 1. Okay, so graphing that. There we go. And this next one, I'll go ahead and subtract 4x from both sides. So I get 2y equals -4x plus 6. And then dividing through by 2, you can actually see that this line is going to be the same. Y equals -2x plus 3. So when I go to graph this one, it's just exactly the same. So this is an example where there's an infinite number of solutions. And can you remember that terminology? Remember who is consistent or inconsistent. Consistent is all about having a solution. So this guy gets to be consistent because it has a solution, and it ends up being dependent. They're just completely dependent on each other. They're together at all times. And then this one has no solution, so it's inconsistent. And they're 2 different lines, so they're independent.